Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, thank you for the opportunity. In this session, I will deliver my presentation in International Conference on Mathematics and Science Education. My name is Lina Fauzia, and I will deliver my presentation about synthesis of 3,4-accent nitrophenyl 4,5-dihydropyrazole-based and its antibacterial activity. Okay, the frequency of antimicrobial resistance, especially multi-drug resistant MDR antibacterial, has increased globally over the past decades. Pyrazole has been reported for broad-spectrum biological activity. With its heterocyclic ring, pyrazole has antimicrobial, antibacterial, antidepressant, anti-inflammatory, anti-malarial, anti-cancer, etc. Due to its activity, many studies have explored the pyrazole scaffold. Pyrazole derivative with 5,4-accent nitrophenyl attached in pyrazole rings showed excellent broad-spectrum activity against gram-positive and gram-negative bacteria. However, a pyrazole compound with a 4-nitrophenyl group attached to third C of the pyrazole ring has never been synthesized and studied. From literature review, El-Sayed, Misra, and Satgir have been synthesized pyrazole. Synthesis of pyrazole derivatives were conducted by refluxing hydrogen hydrate in absolute ethanol for 3 until 6 hours. Or cycloaddition reaction was performed by refluxing chalcone and hydrazide from 4, 8 until 22 hours. And Satgir synthesized pyrazole with reaction of hydrazine and chalcone in glacial acetic acid under reflux for 10 hours to produce pyrazole. So, from this connection approach of target molecule, it can be concluded that pyrazole can be synthesized by cyclocondensation or cycloaddition, chalcone, and hydrazine. The synthesis of pyrazole was performed by reaction of chalcone in 2-butanol as solvent and phenylhydrazine in reflux condition for 30 hours, and completion of the reaction monitored by TLC. The reaction can be conducted without acetic acid in 2-butanol as a solvent, but needs a long time to react. The reaction mixture, which has been refluxed for 30 hours, is poured into ice water and form a red solid that separates from water. This is an advantage of using 2-butanol as a solvent in this reaction. The acetic acid cannot be used in this reaction because the product dissolves in water and does not form a solid. The product of the reaction was red solid with melting point 73 until 78 degrees Celsius. And cyclization of pyrazole is commonly through hydrazone formation as intermediate. The produce of pyrazole is indicated by the presence of C double bond and adsorption of pyrazole ring at a wave number of 1597 and Z and stretching vibration in 1111. Furthermore, the absorption in 2900 are stretching and bending vibration of the CH ring pyrazoline, and then the appearance of CH adsorption of the pyrazoline ring and the loss of C double bond O or carbonyl group adsorption from the anon of chalcone and CH groups of trans alkane showed that cyclization was successful. The HNMR spectra of the synthesis of pyrazolene showed there were 13 signals indicating 13 types of protons. The methylene proton signal from the pyrazoline ring appears at two doplet-of-doplet signals at 3.15 ppm and 3.84 ppm, while the proton signal from CH appears as doplet-of-doplet at 5.33 ppm. The antibacterial test conducted with nutrient agar was used as the culture medium, and then sterilization of medium was done by autoclaving at 15 C pressure, and the temperature was maintained at 121 degrees Celsius for 15 minutes. Antibacterial tests were carried out by agar well diffusion, and tetracycline was used as positive control, DMSO as negative control, and then pyrazoline was tested at Paris concentration in DMSO. The antibacterial test of the synthesized product was carried out by well diffusion method, and then the pyrazoline was tested for their activity against gram-positive and negative bacteria. Due to the color of the compound, it can be seen clearly when injected into the test medium. This is the result of zone of inhibition synthesized product. Pyrazoline showed activity against S-flexneri at concentration of 500 and 1000 ppm and did not show activity against E. coli. Pyrazoline showed positive inhibition against 4 strains of bacteria tested, but the activity was poor if compared with positive control. Pyrazoline has very poor activity against S. aureus and Bacillus subtilis. Evidently, vanillin substituted Schiff base has better antibacterial activity than pyrazoline, that is vanillin derived. The inhibition of bacterial depends upon strain of bacterial, solvent, and also structure of pyrazoline. The structure of the pyrazoline compound is predicted to be one of the causes of the low antibacterial activity. Further studies should be carried out regarding the causes of the low diameter of inhibition zone of pyrazoline compound. So, it can be concluded from this research that synthesis of vanillin derived from cyclocondensation of chalcone, and polydrosine was conducted in butanol in reflux condition for 30 hours. The synthesized product obtained as red solid in 45% yield, and antibacterial test showed poor activity against all bacterial tested. Okay, that is my presentation, and feel free to ask. Thank you for the participation. Wassalamualaikum warahmatullahi wabarakatuh.